Good day, everyone. I would like you to like and subscribe to my YouTube channel. So I'm going to continue to the topic sword. If you are, uh, you did not, um, if you are just seeing this for the first time, I would like you to go and watch the previous video on sword, addition, subtraction, and multiplication of sword. But this one, I'm going to focus mainly on rationalization of sword. Okay, there's actually a rule in thought that square root must not be in the denominator. So must find a way of removing the fraction of having the square root in the denominator. Okay, a fraction can contain sword in the numerator, denominator, or both, but you must not leave it in the numerator denominator. If it's a numerator, you can leave it, but your final answer, you must make sure you remove it. And removing it is what is named as fractionalization of thought. Now, the rule is this. Remember this rule anyway. That is it. But the rule of removing the square root down is multiplying both numerator and denominator by the root. So if I multiply both of them by the root, I will now have 3 times root 5 over root 5. Remember what I told you? 3 times root 5 will give you 3 root 5. And whenever a root, square root multiply itself, the square root will eliminate and you just have the number. That means square root of root 5 times root 5 will just give you 5. So you have, yes, like I told you, it give you square root of 25. Yeah, square root of 25 is 5. So your answer will be 3 root 5. This thing is known as rationalization of sort. Remember, multiply top and bottom by the root you are trying to remove. So like look at this one now. I want to remove root 7. So I'll multiply both top and bottom by the root 1. The thing about this is that remember why I'm doing that is that whatever I do in numerator, if I do denominator, the fraction is still equal. Do you understand? So, but how this thing works is that by the time I multiply the root that is in numerator with the same root, you will remove the root. That is why you are multiplying both of them by that. So you can have it, simplify it like this. You get it? Okay. It's just like eating in the house and washing the plate. You cannot leave the plate ditchy, not being washed. So that is why in mathematics, I don't even know why. I've not asked. Maybe I'll ask. But one thing I know is that you should not leave the root in the numerator. Removing it is what is known as rationalization. I would like you to pause the video and try doing every of this. They are very Rationalization is very common and is actually the very strong aspect of thought. So all you need to do, like the first one, multiply the denominator and numerator by root 3, and root 3 will remove the root that is denominator. So you have 7 root 3 over 3. You do the same thing. You have 4 root 6 over. Now, if you look at this, 4 root 6 over 6. It's supposed to be 42 over 6. But 2 can go in both 4 and 6. The same thing applied here. So you can just simplify, check your answer, and know whether you get it. So, but this one we just did now was purely on when the denominator is just one sword, one root. Now, but when they are now like roots, um, 2 root 5 plus 2 in denominator, then you have to do what they call conjugate. Now, first I need to introduce you to what conjugate actually means. Now, if you look at this, conjugate is when you multiply um, the um, the let me explain it if you like. Now, the conjugate of each other is multiplying a particular set of sword with the opposite of it, negative of it, like having root 2 plus 5. The conjugate of it is going to be root 2 minus 5. So that means root 2 root 2 plus 5, the conjugate of it will be root 2 minus 5, like I said. Anyhow it is, the conjugate of it is usually the opposite, the reciprocal of it. So And this conjugate is very important in our expression of um, in the rationalization of sort. Now, what is conjugate of sort important? Conjugate of sort is important in the sense that if I have this, like I have here now, if I have this root 5 plus 2, root 5 plus 2, um, and root 5 minus 2. The answer that I will get if I expand it the wrong way is still going to be the same thing as root 2 square minus 2 square. So which will give me 2 minus 4. As easy as that. So in the conjugate of sort, you find out that whenever you multiply the conjugate of sort with it, the other conjugate, they are going to remove the square root. So whenever you have a sort like that, so we definitely have to multiply it by the conjugate. That is what this is all about. So when you expand it, it will give you this, and the conjugate will be removed. So conjugate is usually important. That is what if you use whenever you have it, there's supposed to be square root there, and you multiply it, you give it the answer. Now, rationalizing the denominator now, when you have a not just one root, like root a plus 3. So how do we now do this rationalization? So how you now do this one is this. You have to multiply both top and denominator by the conjugate of the denominator. Okay? So let's look at what I'm talking about. We have learned how to rationalize this. This one is easy. So you can do that. We have learned how to rationalize something like this. We can do that. But when we now come to when you have something that is, let me get to that space. Okay, when you want to rationalize this, then you must multiply the denominator and numerator by the conjugate. Look at it now, by the conjugate of the numerator. Why do we do that? Because I know that when the conjugate multiply each other, they are going to give me a number that root, and that is how it's going to be like. So that means for you to do this, you need to remember the rules of um multiplication. But my advice to you is you use ideology of difference of two squares. So instead of doing this that I just did now, you can just remove it and just go straight and use difference of two square to rationalize it like this. So instead of trying to do all of them one after the other, you can just do with 5 square and that. So instead of having repeated removing those twos in the middle, you can just go straight ahead and do that. What do I mean by what I'm saying? Now let's look at this denominator. Let's look at it. In the denominator, you have it was expanding it gradually one after the other. How about what if he does it like this? Root 5 square minus 2 square would have given him 5 minus 4, which should have got straight and gotten 1 straight away without wasting your time trying to do that. Now, I would like you to pause your video and try doing this one. Multiply the denominator and numerator by the conjugate of denominator, I mean to say, and you try it out. Instead of doing it one by one, you can just write root 3 square minus root 2 square. But remember, it's always going to be um, negative. You cannot say positive there. So which will give you 3 minus 2, and you get your answer on denominator to be 1 without looking at it much. I can just see it from the working. So try this one. So I've done it for you already. And I would like you to try this one and look at how it works. Now, in summary, the rules of indices, like the one I've taught you before, I would like you to look at them. They are going to be useful for you. Once you understand those rules of indices, it's going to help you in solving almost every algebraic expression or equation. And the rules of sort, these 3 rules of sort, they are used, that important in addition, subtraction, rationalization of sort. I think I'm going to stop here. The next video I'm going to do is topical question on sword and others. I would like you to stay tuned and continue to watch and learn simple ways of understand math. Thank you.